The next example that is given is the area in the first quadrant. Okay. So the area that we are going to consider that is at the first quadrant, bounded by x squared is equal to 8y. The line x is equal to 4 and the x-axis. Okay. What are the boundaries for this given? So the boundaries for this problem, that is the parabola, a line, and x-axis. The parabola, that is x squared, is equal to 8y. And the line x equal to 4 and the x-axis. That is the boundary. So what is being asked? What is the volume generated by revolving this area about the y-axis? We are going to revolve the area about the y-axis. So here, given is the area in the first quadrant. Okay, we are going to consider only the first quadrant area. So what is the volume generated by revolving this area about the y-axis? Okay, so the figure. Okay, let's start with the figure. So our figure here, we have y and x-axis. X squared equal to 8y, that is a parabola, because a parabola that is facing upward, y upward. Okay, the x-axis curve here. Why we know that x-axis curve? Because x-axis has an exponent. Okay, and then we have positive at the right side, so therefore that is facing up. If this is negative, that is facing downward. Okay, there is now a parabola at the origin, 0, 0. So therefore, we have our parabola going up. Point of intersection. How will we know that that is the point of intersection? Okay. You just simply substitute the value of 4, okay? The value of 4 to your x-axis, because x is equal to 4. So 4 squared, that is 16. Divided by 8, so you will have 2. So therefore, the point of intersection, that is 4 and positive 2. Okay, you get that one? X squared is equal to 8y. So point of intersection at line is equal to x is equal to 4. So substitute the value of 4 to your x here. So 4 squared, that is 16. Divided by 8, so you will have 2. So therefore, your point of intersection, that is 4 and 2. So your boundary here, your boundary, that is line, okay? Line, x is equal to 4. The curve, the parabola, that is x squared, is equal to 8y. And the x-axis, okay? So this is now your area of interest, okay? This one. Because your boundary is the parabola, the line, and the x-axis. So what is being asked here? What is the volume generated by revolving this area about the y-axis? Okay. So if we are going to take a vertical strip here, okay, because that is vertical, you cut the x-axis. So if that is vertical, so you will have dx. So formula, because if we are going to revolve this one, this vertical axis, revolve this one about the y-axis, then we can have a formula that is cylindrical shell, right? So therefore, the formula in solving for cylindrical, you will have volume is equal to the integral of 2 pi x sub c, that is the radius of your cylinder, y up minus y down dx. We'll be using dx here because that is a vertical strip. Okay. So therefore, if we will have dv, so dv is equal to 2 pi x sub c y up minus y down dx. So if we are going to integrate both sides, so you will have v is equal to 2 pi limits. Okay, limits. So the start of your area of concern, that is 0, 0. So that is dx. So limit is your limit will be in terms of x. So you will have 0 to 4. Okay, right? So that, because that is dx, so consider the x. So you will have 0 to 4. So that's the reason you will have 0 to 4. Okay, what is the radius of your cylindrical form? Okay, at any vertical strip, you can form a cylinder. Okay, you can form a cylinder. So the radius is equivalent to, what is the equivalent of your radius? Equivalent to x. So that's the reason your radius here is x. Y up. Okay, y up. Okay, y up, that is at the uppermost portion, your vertical strip touches what equation? Okay, the equation of the curve. And what is that curve? X squared is equal to 8y. Okay. And because that is, we are looking for in terms of x, so express x squared equal to 8y in terms of x. So you will have your y up, therefore you will have x squared over 8. Okay. Y down, so y down, what is the equivalent of the equation here? Your the lower part of your vertical strip touches x equal to 0, right? Because that is at the origin part. So you will have 0 here. So that's the reason you will have 2 divided by 8, that will come 4. So pi over 4, evaluated from 0 to 4, x times x squared, x cubed, dx. The integral of x cubed, that is x to the 4th, okay, over 4. So that's the reason 4 times 4, 16. Evaluated from 0 to 4, so you will have 4 raised to 4, 0 raised to 4. And your answer, that is equivalent to 50.26 cubic units. Okay? Okay, the next example, that is the area bounded by the curve y squared is equal to 12x. The line x is equal to 3 is revolved about the line x is equal to 3. Okay, so what is the volume generated? So if we are going to look at here, the area bounded by the curve, okay, our boundary here, that is a parabola. Still, that is a parabola. If we are going to look at that one, that is a form of a parabola. A parabola wherein, what curve here? Okay, if you are going to look at this one, this is a parabola that is facing, is it facing upward or facing right? So, what is being curved here? The y-axis. Why y-axis? Because your y has an exponent. Okay, because your y here is squared, meaning your y is the one that is being curved. And then that is facing at the right side. Why right side? Because that is positive. But then if you will have negative here, that is facing to the left. So, this is now a parabola. So, parabola, point of intersection. That will intersect because your another boundary is x is equal to 3. So, if that is equal to 3, so therefore you will have 12 times 3, that is 36. Square root of 36, that is plus minus 6, right? So therefore that will intersect at 0, that will intersect at 3 and positive 6. Okay. So here, we will be using, what is the volume generated? We will be using vertical strip here. If we are going to use vertical strip, because, so you will have, okay, formula here, formula. If we will be using vertical strip, what is being used here? The area bounded by the curve y squared is equal to 12x. So, boundary is a parabola. Another boundary is line, x is equal to 3. But it is not stated that our problem is only for the first quadrant. So, therefore, if that is not only for first quadrant, so your area of interest is this one. The first quadrant and the fourth quadrant. Okay. And the fourth quadrant. So, if we are going to use vertical strip, so we will be using cylindrical. Okay. So, cylindrical shell. So, that will be revolved about the line x is equal to 3. So, the same procedure as what we have a while ago. You will have from your y-axis to your line, that is x is equal to 3. So, any vertical strip that you will be forming here, from your y towards your vertical strip, that is equivalent to x. So, the radius of the cylindrical shell that can be formed, that will be equal to 3 minus x. So, this is now the one that we will be forming. So, vertical strip, revolve about x is equal to 3, revolve about x is equal to 3, then we can form a cylinder. So, limit here, the limits that we will be using, that is from origin, because this vertical strip that cut the x-axis, so that is dx. So, if that is dx, so your limits, that is on the x-axis. So, 0 to 3, that is your limit. So, formula that we will be using here, okay, the formula that we will be using, that is the integral of 2 pi x sub c, that is the radius being formed, y up minus y down dx. So, dv, if we will have dv is equal to 2 pi x sub c, y up minus y down dx. Radius that is being formed, so 3 minus x, that is the radius, right? So, if we are going to look at here, I put 2. Why 2? Because your first quadrant, that is a mirror of the fourth quadrant. So, you just multiply by 2. Because if you will not put 2 here, so that is not correct. Because the lower part is a mirror, then we will have y up, okay, because I evaluated this one only at the first quadrant, then multiply 2 only, so that you will have whole area is being covered. So, therefore, you will have y up, the vertical strip touches the curve. So what is now y up here? Y up, that is equal to y squared is equal to 12x. So y is equal to the square root of 12 x raised to 1/2. Y lower part or y down, that touches the x-axis. Okay, right? Which is x is equal to 0. Then dx. So 2 times 2, that's the reason you will have 4 pi 3 minus x square root of 12 x raised to 1/2 dx. Integrate both sides. So when we are going to integrate dv, that would become v. So v is equal to 4 square root of 12 pi, the integral of 3x, okay, multiply x raised to 1/2 inside. So 3x raised to 1/2 minus x raised to 3/2. That is 1/2 plus 1. That is 3/2. So the integral here, that is evaluated from 0 to 3. Okay. So therefore, we will have volume, therefore, is equal to 4 the square root of 12 pi. The integral of 3x raised to 1/2 plus 1. So 1/2, that is 3/2 over 3/2. 3/2 plus 1, that is 5/2 over 5/2. So 3 here can be cancelled out. Okay. So then here, so that's the reason you will have 2 up. So 2x raised to 3/2 minus 2 over 5 x 5/2 evaluated from 0 to 3. So for that case, if that is evaluated from 0 to 3, you will have 4 the square root of 12 pi. Okay. You will have 2, 3 raised to 3/2 minus 2 over 5, then 3 raised to 5/2 minus lower limit all 0. Okay. That's the reason your answer, that is equivalent to the volume 180.96 cubic units. Okay.